was something that should be recorded, and you wrote y equaled mx plus b. And of course you recognize that the only difference between that was supposed to be yellow. The only difference between that and that is that y was isolated. So of course you took this and you divided by 2, so y was alone, and then you divided this whole side by 2. And some of you will have forgotten that 2 divides the entirety of the left-hand side. So the answer is 3 over 2. 3 halves x minus 2. And then, of course, you graphed it by going to negative 2 and rising 1, 2, 3 and running 1, 2, or dropping 1, 2, 3 and running 1, 2 to make that line. Right? Amazing! Graph using x or y intercepts. Every single x-intercept is x, comma, 0. Every single y-intercept is 0, comma, y. If you are seeking an x, what happens to the y value? It disappears. So I get 6x plus 12 equals 0. 6x equals negative 12. X equals negative 2. And I, of course, go over. Should I put the dot here now? No. Why not, Ms. Alexo?
We don't know how we want to scale the graph.
You're darn tootin' we don't know how we want to scale the graph. Now, I would have liked to have had a celebratory sip of tea, but I'm out.
No.
When I seek a y, what happens to the x? It disappears, so I have 3y plus 12 equals 0. 3y equals negative 12. Y equals negative 4. Since they are both nice, easy to work with whole numbers. Hey. Dummy head. Since they are nice, easy to work with whole numbers, I don't need to change the scale. Yeah? Yeah. What's the slope of that line? This wasn't in the question. I'm actually asking you to think. What is the slope of that line? All of you on your quizzes and tests are going to say that line has a slope of positive 2 because you're going to do y divided by x and get positive 2. Yes, you will, because I've been marking quizzes on this for the last 20 years, and every time I ask this question, kids tell me the slope is positive. What is the slope really? Because it is leaning that way. Fair warning, on upcoming quizzes and tests, I'm going to ask you a question that asks you to tell me the slope when you have been given x and y intercepts. I guarantee you, even though I am doing this big speech right now, and it is being recorded, a significant proportion of you will tell me that slope is wrong. Okay? Mark your date, November 18th, 12:11 by my watch. And when we mark the quizzes, what will I get to say? Yeah. Do I want to say I told you so? No, I don't want to at all. I really don't. I mean, I enjoy it when I get to, but I don't want to, right? It's kind of like pizza. I don't want to eat pizza because it ruins my guts, but I really like to eat pizza because it's still yummy, even though it ruins my guts. Ah! I have no idea where we're... Oh, independent practice, right. That's why everyone was quiet. there's 2 x's and 2 y's. What do? I label them. Now, I am going to label them counterintuitively, which means I am going to say that this first x I see is x2, which makes this y what? Y2, which makes this x what? And this y? 1. And then, because I am an intelligent, young, yet old person, I am going to show my work without even once saying, to have to show work. I'm just going to show my work because I listen to the teacher, and the teacher says when I show work, I can't possibly get it wrong. M equals y2 minus y1 over x2 minus x1. Mr. Myers, I will never remember that formula. Kid, you don't have to, because like all math teachers, you will get those formulas. You just need to know how to use them. Negative 5 over 4, because that's m, equals y2, 1, minus y1, y, over x2, negative 3, minus x1, 5. Negative 5 over 4 equals 1 minus y over negative 8. 40 equals 4 minus 4y. 36 equals negative 4y. Y equals negative 9. Yes! Everybody, please go to the next page. I'm going to take this moment. That font is called a dripping marker, but I like to use it because it looks like graffiti. It is a boring name, but I don't name the fonts. I just pick them from a vast library of fonts. Millions. But a lot of them look the same or similar. All right. The problem with the dripping marker, of course, is it's hard to read. That says parallel and perpendicular slopes. Yes, parallel is easy. What does parallel mean? 2 lines that are beside each other. How far apart are they? As far apart as they need to be. How equal distant apart? For how long? Forever. If they are always the same distance apart, what will they never do? Touch. Excellent. So we already know all this stuff, so it's super easy. Everybody, take your pen, pencil, stone tablet, and chisel, whatever it is you write your notes with, and put a dot anywhere on the left-hand side of this Cartesian plane. Anywhere. My favorite question is when I tell you to do this and I see a bunch of people that are so paralyzed by the choices they can't even do it. Put a dot anywhere. All you have to do is that. Now, from your dot, put another dot that has a rise. No. Yes. A rise of -3 and a run of +2. Now that's a trick question because you're not allowed to go off the graph. So you have to figure out how to make a rise of -3 and a run of +2 work. For me, it is down 1, 2, 3, and right 2. Now, every single one of you should have a line with a slope of -3 right? Excellent. Now, all of you put a dot at 4, 1. He waits patiently for his students to write a dot. 1, 2, 3, 4, 1. And then put another dot at -2. And what will be the pot, or what will be the 14? Wait a moment. I have to put sugar and milk in my tea.
What kind of tea is it?
Tengal spice.
Is it good?
It's delicious. We are at 4, 1. I want another dot at -2. We have our dot at, have we found -2? Yeah. Now, that is what kind of value? X or Y? So the rest, to be able to write this dot, you need another number from me, yes? But how can you show on the graph where x is -2 when you cannot tell me the y value? What would you do to show me that you know half of this, what I'm asking you to do? RJ. A dotted line. A dotted line at where? -2 on which scale? Vertical line, because it's where x is -2, yes? Now, is there any way to put a point on that dotted red line which will give me a parallel slope? No, why not? Okay. Why else not? RJ.
So that line will go right through, almost, it will go through that plane, that refracted.
It would be a different slope.
It would be a different slope if I were to put the dot anywhere on this line as it stands, yes? Everyone agrees? Okay. Let me ask you this. Now you must visualize this graph as being bigger than it is. Can you put a dot on that dotted line if the graph's boundaries are expanded? Yes. Where would that dot be? No, it would not be anywhere, because that would be a dot and then it would not be a parallel slope, would it? Where would the dot have to be on there to keep the parallel slope? Mantaj. This is the dot with which we are working, 4, 1. I need to put a dot somewhere on this line that will allow me to draw a red line that has that slope. Where would it be? I want coordinates. We remember that slope equals rise over run. And what is the slope that we have right now in black? -3/2. You have all already told me that a parallel slope must be the same, yes? And I have told you we have a dot here, and the next dot has to be on this red line. Jordy.
Well, so then you would follow the slope until you reach that red line.
Absolutely correct. So I went this way how far? Oops, to make a red line. I went that way 6. Is that a rise or a run? So -6. So what do I need to go up to keep this fraction? 9. So what would be the coordinate over here? 10. -2, 10. Because I was at 1. Is everybody with me? That is how I would make parallel slopes. Everybody cool? You just make the slope the same. Yeah? Okay. Parallel's the easy one. But everybody forgets that if I say 2 lines are parallel, you know 2 things right away. You'll all say they'll never touch, and now you'll say they have the same slope, right? But if I were to say 2 lines have the same slope, what do you know about them? Half of you would say, oh no, I guess I could graph them. But they're 2 sides of the same coin, aren't they? If 2 lines are parallel when they have the same slope, then when they have the same slope, they are parallel. It works both ways. Believe it or not, that second one seems to cause issues. I do not know why. Everybody cool? All right. Perpendicularity, to explain it, takes 2 examples. All right? So let's start, first of all, with asking you people, what does the word perpendicular mean? Jordy. It means this. So what does that mean? Yes, anytime 2 lines meet at a right angle, you have perpendicularity. Wall meeting the floor in most buildings, right? Everybody cool? Okay. So what's the easiest definition of perpendicularity? What Jordy just showed us. This, right? So everybody draw the line x equals -5. On the second graph down here. Yeah? Easy peasy lemon squeezy, right? Okay. Now, for argument's sake, even though we all know, actually, I'm going to stop for a sec there. What do we know about that slope? It's undefined. Why? We talked about it on Friday. What makes it undefined? It's over 0. We cannot divide by 0, right? It's an infinitely large number, right? So this, no matter what we say, no matter what points we choose, this slope, right, is some value over 0, yes? No matter what points I use. If I choose 1 and -1, it's 2 over 0, isn't it? If I choose -5 and +5, it's 10 over 0, isn't it? Does it matter what value goes here, or is this always going to be infinite? Always going to be infinite. Everybody agree? All right. Now, draw me the line at y equals 5. Where is that line? What is that guy's slope? Jordy?
Same thing as, it would be,
Why would it be 0? How far does it rise? 0. Over what is its run? No. No. Armand. Some value. No matter what I put here, if I chose 3 and 4, its run, or negative 6 and negative 4, its run would be 2, right? So it would be 0 over 2. Everybody understand? Now, we know that horizontal and vertical lines meet at 90 degrees, yes? What do you see about their slopes? No, only their slopes. What are they? We know they're perpendicular, but the slopes can't be perpendicular. Slopes have values that are perpendicular. What do you see? Just describe. She too? Pardon me? No, because this one is defined. Look at what you see. Just tell me what you see. No, we are only talking about the slopes, ladies and gentlemen. What do you see about the slopes? Caden. They have 0 and they have value, right? Okay. What would you say about the difference between the two? Come on. Opposite is not quite the right word. In math, opposite means positive or negative. But I know what you're thinking. They are reciprocated. Yay. Nice job, Selena. Because I believe that you told her and you just didn't want to say it out loud.
No, I told her.
Oh, really?
I wanted her to say it because if I was wrong and she was embarrassing, then I called like 3 times in a row.
Okay. Have I bugged you once for being wrong?
But I bugged myself.
What gets you bugged in this class?
I don't know. It's okay.
No. I want to make this point. What gets you bugged in this class? This is what gets you bugged in this class. What? Not answering. That gets you bugged. All right, is everybody good? But I told you, the definition of perpendicularity is twofold. Yes? Twofold. All right? So now, everybody put a dot, because that's half the definition. Everybody put a dot at the origin. Yeah. See if people know. And then tell me the coordinates of the origin. Excellent. So we are putting a dot at 0, 0. Ta-da! Now, put a dot at 5, 7. Agreed? Yeah. Yes? Okay. Now, do me a favor and put a dot at 5, 0. I'm going to change color. Yeah? Everybody cool? Okay. And now put a dot at, where do you think I'm going to ask you to put the next dot? 0, 7. Everybody cool? That would be right there, yes? Connect them. Is it a square? Really? How far did we go this way? 5. How far did we go this way? 7. Right? Everybody agree? Okay. So what is the black line's slope? 5 over 7. Yes? Okay. So the black line has a slope of 5. Oh, it's supposed to be black. Has a slope of 5/7. Agreed? What is the green line slope? Negative 5/7. Now, RJ said we made a square. Right? Now, I'm not putting them down. But if we made a square, then if we cut it in half, these guys would all be 90 degrees, wouldn't they? Yes. And if they were 90 degrees, they would meet perpendicularly, yes? Perpendicular slopes we know have to be reciprocals of each other. Are they? Are those reciprocals? You can't just say yes and no repeatedly until I stop. Somebody come up and stick with it. Give me an answer, yes or no. Are these reciprocals? No, of course they are not. Why? No. They aren't reciprocated. The 5 and the 7 are in the same place. But what are they, Kamal? They are opposite. Now, you're intelligent young people. RJ thought we were in a square, and you can see that if a diagonal line is going to meet, then one must be positive and one must be negative, yes? And we already know they have to reciprocate, right? So I want you to figure out where I am going to put a purple or an orange line that is perpendicular to 5/7. So I'm going to erase the green line. You give me some coordinates to draw an orange line that is perpendicular. Now, you're smart kids. You already know the two things you need to know. And it was the Jeopardy theme done with... Because when I whistle at people, people are bothered by it. Would anybody like to risk solving this very difficult question I've posed to you? Okay, let's see. What is the first thing we know about a reciprocal slope? What must it be? I just said it. What is the first thing we know about a perpendicular slope? It must be what? Reciprocal. So what is going to happen to 5/7? It is going to become 7/5. What else did we prove with our previous experiment? The other slope must be negative. So what do I write here? Negative. Now, slopes are what? Slopes are slopey. Yes, indeed they are. By definition, slopes are slopey. Just like you are Simmery. And I am Maddie. And he is Connery. Because what else could he be? Well, I don't know. I guess he could be James Bond. Connery. Thank you, Caden. One person got it. All right. Seriously. I want a perpendicular line. All slopes are what? Rise over run. So the easiest place to start my orange line would be at the origin, yes? How far must I rise? -7. Okay. 1, 2, 3, 4, 5, 6, 7. How far must I run? 1, 2, 3, 4, 5. And that gets me that line right there, yes? Does everyone agree?
Yeah.
Okay. Now what do we know about the black line? Will it continue this way? It's supposed to be black. Will it continue this way? Will the orange line continue this way?
Yes.
And now what do we have right there? It's a right angle. Right? Because this was 7, yes? And what's this? Okay. Everybody agree?
Yes.
All right. And we're good. Because we have now shown that they must reciprocate and change signs. So let's put it all into perspective. Parallel lines have what? The same slope. Now, must it be in the same form?
No.
Are the two lines I am about to describe here parallel? Line 1 is 3 halves. Line 2 has a slope of 1.5. Are those parallel? Yes. Why? Because those are the same values. Everybody understand? Even though they don't look the same. Is line 3, which I am bringing to the party over here, which is 90 over 60. Is that going to be parallel to the first two? Yes. Even though the numbers are all different, right? Excellent. Perpendicular lines, on the other hand, have slopes that are opposite and reciprocated. Now, some people say their slopes are negative reciprocals. I don't like to say that because if the first slope you have been given is negative, a great many of you forget to change it to positive. Because you don't actually remember this lesson. You stop listening when you hear the shortcut. Negative reciprocals. Okay? So that's why I say opposite and reciprocal. Because if you start with a negative, you're going to end up with a positive. If you start with a positive, you're going to end up with a negative. Right? Yes. All right, so let me ask you this. Are these two lines perpendicular? Are they? Well, we're on the perpendicular side here, Jewel. Are they perpendicular? Yes or no? Now, start. Yes? Are you sure, Nika? 100%. You're going to bet the farm.
Yes.
It's a saying.
Yeah, sure.
You're 100%. No, because they are both positive. Oh, you thought that little dot? No, it's just my pen dying. There. But if I did this, are they perpendicular? Yes, good. I don't know why my pen is such crap. Well, I do know why, but I don't like to keep saying that. You guys should be able to fill in these six numbers, or six slopes. Go. Should take 5 seconds per line. 30 seconds. Go. Halfway there. Zero is nothing. What do you think the opposite of nothing is? Everything. What number is everything? Infinity. And what do we call infinity? Undefined. That was well over 30 seconds. What is this number here? Negative 3 halves. What is this number here? 1/7. What is this number here? No. 4. Parallel. This number here. 11 fifths. This one here. Undefined. And the last one? 0. Yay. Turn the page over. I am asking you to tell me if line ST is parallel, perpendicular, or neither. If it is parallel, which I will write in green, then what do I know about the slopes? The M of AB would equal the M of ST, yes? Right? So the slope of AB would be what? Rise over run, which doesn't really help us because it's not graphed, is it? So what would be a better way to find the slope of AB? Right! The y2 minus y1 of AB, 2 minus x1, would equal what? The y2 minus y1 and x2 minus x1 of ST, yeah? That's if they're parallel. What if they were perpendicular? Does the first one change? This is for parallel. That's the symbol for parallel. Two lines, vertical lines beside each other. What if they were perpendicular? That's the symbol for perpendicular. Then would the first one change? No, I'd still use y2 minus y1 over x2 minus x1. And this one would be then what? If they were perpendicular, what would ST's slope be? What would you do with these numbers? It would be x2 minus x1 over y2 minus y1 and the opposite, right? Everybody with me? And if they're neither, who cares, right? So, which one should we try first? We should try parallel because everything's the same, yeah? So what goes in for y2 on AB? On AB. Negative 1. Okay, negative 1. Oh, I should be doing that in green. Sorry. Negative 1. That means this is y2, correct? So what is the y1 that we are dealing with? 1. Negative 1 minus 1 over 5 minus 1, which is what? Negative 2 over 4, which is what? Negative 1/2. Everyone agree? So this side is negative 1/2. So now we check the ST side. What are the y1 and y2 over there? 5 minus 1 over negative 1 minus negative 4. What is 5 minus 1? 6. Over what? 3. What's 6 over 3 really? 2. And what's 2 really? What do you see? It's a reciprocal, and one is? And one is? So are these guys perpendicular or parallel? Do we even need to check this one? No. Why did I show you this one? Because I need you to understand that you can use the same values, and sometimes that will be helpful to you. Everybody good? Yes. All right. Let's look at the next question. The vertices of a triangle are the corners, yes? If it's a right angle triangle, what do we know the angle is at one of those corners? 90. Right? Okay. Which means 90 means two of those lines meet at a 90-degree angle, or perpendicularly, yes? Okay. How many corners are in a triangle? So how many corners do I have to check? One of them has to be 90, but how many do I have to check? All three. Is there a way I can lower my workload? I don't want to check 3 different slopes. Is there a way to lower my workload?
Get one of them subtracted from 90.
Okay. You started and then said no, so I'm just going to stop.
It's on your face, so I thought it was wrong.
So try again.
You find one of them. You take 90 and subtract it, and it'll give you the third one.
No. Because slopes will not give us an angle. Try again. Tamana. The 2 coordinates to make the right angle. But how do you know if it's a right angle? No, you do know. You do know. What would tell you that 2 lines are meeting at 90 degrees, RJ? If they're perpendicular slopes, yes? But we don't want to check all 3. So Tamana's right. We want to check only one. But how do we know which one to check? What does this give us? Coordinates on a graph, yes? Okay. Where is -3, 1? Where's -3, 1? 1, 2, 3. Do we agree they're pretty close to equal amounts? And up 1, yeah? There's A. Agreed? Where's B? 1, 2, 3, 4, 5, 6. 1, 2. Do we agree? Yes. Where's C? 1, 2, 3. 1, 2, 3, 4. Now, which is the only even possible 90-degree angle? Right there, yes? So what are the only slopes I have to check? I got to check the slope of, what's this line? AC. And I got to check the slope of BC. And if they are negative reciprocals, is this a 90-degree triangle? So let's go. What's the slope of AC? Four minus 1, okay, over 3 minus -3. What's 4 minus 1? What's 3 minus -3? What's that really? 1/2. So if BC is what? -2, this is a 90-degree triangle, right? Let's check. What's BC? -2 minus 4, okay. What's -2 minus 4? -6. What's 6 minus 3? What's -6 divided by 3? -2, and -2 is properly -2 over what? Are they perpendicular? Yes. Right. This is the type of thing that people do in real life when they are using maps for property, bearing, like if you're orientation by map, right? This is the type of stuff that people need to do. It comes into play in a lot of navigation and things like that. Everybody cool? All right. Turn the page over. I have an unknown value. I want AB to be parallel to CD. So what does that mean? I know about the slope of MA and the slope of CD. Oops, I shouldn't have written it that way. The slope of AB and the slope of CD must be what? Equal. Which of those can I find right now? Why can I only find AB, Vicky? Exactly. So I can find the slope of AB. How do you want to do it? The first person that talks, I'm writing.
F equals y subscript 2 minus y.
Absolutely the right thing to do, because now you can't do it wrong. Now what are we putting there? 10 minus 5 over 7 minus 3. What is 10 minus 5? Over 5/4 is the slope I seek, yes? And if it's parallel, it must be equal to what? It must equal the slope of CD, correct? Well, what is the slope of CD? It's y2 minus y1 over x2 minus x1.
Yeah.
And what do I put there?
A minus 2 over 1.
1.
Minus 2.
Just 1. Not 1 minus 2, 1 minus 0.
Oh.
X's. Now, how do I solve every single problem in algebra ever when you have fraction equals anything? Great. What's 5 times 1? I know, it was a tricky question. What's 4 times a minus 2? What's your job every time you see a single variable? Let's start isolating. Thirteen equals 4a, and a equals, which we could also write as 3 1/4, right?
Yeah.
Does the point on the graph 1 and 1, 2, 3 1/4 exist? Sure it does. So is it possible this is our right answer? A bunch of kids will tell me it's not. Oh, it can't be a fraction. Well, yeah, it can. Because every value of x is available and every value of y is available, yes? Okay, what's going to happen in B? Now what do I want? If AB is perpendicular to CD, then the m of AB must equal the negative 1 over the m of CD, correct? Everyone agree? Well, what's easier to flip? The one with the unknown or the ones that are all known? Ones that are all known. So we were 5 over 4, weren't we? So what do we need it to be now? Negative 4/5. Does the CD change at all? What was it? What was it? No, this. A minus 2 over 1. What is the way to solve this every time? What is it? Keep going.
A equals negative 2.
6 equals 5a, and a equals, or 6/5. Does 6/5 exist? 1 1/5. So you would go over 1 and up a little bit. Or you would change your scale to be fifths, which means where would your 1 be? 1, 2, 3, 4, 5. That would be 1. 6/5 would be 1 more fifth. Everybody cool? All right. And that's it for parallel and perpendicular. You either flip and change the sign or you don't. That's it. Have a look at page 151. If I were you, I would spend a lot of time with The ones where you see nothing. No graph at all. But, whatever. Everybody cool? Go. I don't know how much time you have.